It is a delta built not into water, but onto dry land. Quantum theory is staggeringly precise. It predicts a certain magnetic property of the electron to a dozen decimal places, confirmed by experiment. Yet apply that same theory to gravity and it falls apart. The calculations that no trick can fully remove. The method that tames infinities for other forces simply fails for gravity, because gravity grows stronger at the very scales where the quantum chaos is wildest, feeding back on itself. So the most accurate theory ever built cannot be extended to the most familiar force. That contradiction unresolved, the moon shows us a single face, always, and it is no accident of luck. The same hemisphere has greeted Earth for billions of years. Long ago, the moon spun faster, but Earth's gravity tugged harder on its near side than its far side, slightly stretching it. That stretch acted like a brake, dragging on the spin until the moon's rotation matched its orbit exactly. Now it turns once for every loop around us. The far side is never hidden in permanent darkness. It is simply turned forever away from us. A snake's tongue isn't for tasting in the way ours is. It's for smelling in stereo. Flicked out, the forked tip collects scent particles from the air and ground, then slots them into two pits on the roof of the mouth called the Jacobson's organ. Because the fork has two tines, the left tip can gather a stronger scent than the right. The snake compares the two sides just as we compare loudness between our ears, and turns toward the stronger trail. A split tongue becomes a compass pointed at prey. An organ's deepest pipes are longer than a person is tall, and the length is no accident. A pipe makes its note by setting a column of air vibrating, and the longest waves need the longest columns to fit. The lowest notes the ear can hear stretch many meters from peak to peak, so the pipe must be sized to match, sometimes 10 meters or more. Halve a pipe's length and its pitch jumps an octave. The towering pipes you see are not for show. They are the physical size of the lowest sounds built in wood and metal. A drop of water can hold light prisoner. When light inside water meets the surface at a steep enough angle, none escapes. It all reflects back inward. A phenomenon called total internal reflection. Beyond a certain critical angle, the surface becomes a perfect mirror from below. This is why a fish tank's top can look silvery from underneath, and why light races through glass fibers for miles. The light is simply too slanted to break out into the thinner air. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. That lone pillar of rock standing offshore was once part of the mainland. It is a sea stack, and it marks where an arch used to be. Waves wear a cliff until they open a tunnel through it. The arch survives only as long as the rock spanning the top can hold its own weight. Eventually, the roof collapses. The seaward leg is left isolated, cut off from the cliff that bore it. A sea stack is the last standing fragment of a coastline that the ocean has already carried away. Epictetus drew a clean border around what is actually ours. Some things are in our power, he taught, and some are not. Our judgments and desires are ours, while our bodies, fortune, and fame are not. Peace begins the moment you stop defending the territory you never held. The fallout there is in the second column, outside any grip. What remains in the first is how it is met. A supernova can briefly release more energy than the sun will emit across its entire 10 billion year lifetime. The source is gravitational collapse. When a massive core falls inward, an immense store of gravitational energy is suddenly liberated, most of it carried away by neutrinos in seconds. Only a small fraction becomes visible light, yet even that sliver can outshine a whole galaxy. For a few weeks, a single exploding star can be seen across vast stretches of the universe. Most of the helium and carbon you encounter began inside stars through a process of patient assembly. In stellar cores, hydrogen nuclei fuse into helium, and in older stars, 3 helium nuclei collide to form carbon. This stepwise building of heavier elements from lighter ones is how the cosmos grew chemically rich. The earliest universe held almost nothing but hydrogen and helium. Everything more complex, including the carbon in every living thing, was manufactured by generations of stars. Many flowers refuse their own pollen, and they do it with chemistry. When a grain of pollen lands, the flower reads a chemical signature carried by it. If that signature matches the flower's own, the pollen tube is blocked and cannot grow down to the egg. Only pollen carrying a different signature is allowed to continue. By rejecting itself, the plant pushes its seeds to come from another individual, mixing 2 sets of genes. Self-denial, written into a single recognition code, keeps the lineage from folding in on itself. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Roman numerals are wonderful for carving and terrible for arithmetic. Try multiplying 48 by 93 using only x, v, and I, and you will see the problem. There is no column for tens, no place where a symbol's position changes its worth. The number system we use instead came through Arabic mathematics from India, and its magic is place value. The same digit means 1, 10, or 100 depending on where it sits. That single idea, position-carrying meaning, is what let ordinary people calculate without an abacus. And why the moon's glow reaches you about 1 1/4 seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. The calcium in your bones and the iron in your blood were cooked inside stars that died before the sun was born. Lighter elements like carbon and oxygen form in the fusion furnaces of aging stars. Heavier ones are scattered when those stars explode, seeding clouds of gas with fresh ingredients. From such enriched clouds, new stars and planets form. You are quite literally assembled from the ash of earlier stellar deaths, a fact that links your body to events billions of years gone. A cow cannot digest grass on its own. The animal that lives on a meadow is really a walking vat of microbes. In its great fermentation chamber, the rumen, vast numbers of bacteria and protozoa break down the cellulose the cow itself cannot touch, releasing nutrients the cow then absorbs. The cow supplies warmth, a steady food stream, and a sealed home. The microbes supply the one chemical trick that unlocks grass. Every grazing herd on Earth is, in truth, farming an invisible garden in its own gut. The image landing in your eye is upside down. The lens at the front flips light so the world arrives on the retina inverted, top swapped with bottom. You never notice because seeing right side up isn't about the picture's orientation at all. It's about how the brain maps that image onto your sense of up and down, gravity in your own body. The brain learned the mapping long ago and simply uses it. Up isn't a direction printed in the image. It's a relationship the brain assigns. The eye delivers an upside-down world, and you live in it perfectly upright. Two crews could meet inside a mountain because the Romans trusted geometry over guesswork. Before digging a tunnel, a surveyor traced the intended line across the surface above, measuring the horizontal distance in any rise. Using the relationship between the sides of a right triangle, he could fix the depth and direction each crew should follow underground. They were in effect solving for an unseen path with marks made in open air. When the two tunnels met in darkness, only a step apart, it was not luck. It was a triangle drawn on a hillside, made real in rock. A few deserts get most of their water without a single drop of rain. Along certain cold current coasts, thick fog rolls inland off the sea day after day. Specialized plants and lichens comb moisture straight from that mist, and people string up fine mesh nets that do the same, dripping captured fog into tanks below. The sky here almost never opens, yet the air is heavy with water. Where rain has given up, fog quietly keeps a whole community alive, one beat at a time. Orchids make seeds finer than dust, and they can afford to. A single orchid pod may hold many thousands of seeds, each so small it carries almost no food for the sprout. Scattered on the wind, most land where they will die. But the few that touch the right fungus strike a bargain. The fungus feeds the helpless seed until it can grow leaves and feed itself. The orchid bets on numbers and a partnership, flooding the air with near weightless seeds and trusting the soil to nurse the lucky ones. Fall toward a small black hole feet first, and gravity pulls your feet far harder than your head. The difference stretches you lengthwise while squeezing your sides. A process scientists named, half grimly, spaghettification. It happens because gravity weakens with distance, and near a compact hole that change is brutally steep across even a human body. Around a supermassive hole, the stretch is gentle at the edge. Around a small one, it tears matter apart long before the horizon. The same falling, two fates, decided by how sharply the pull shifts from your toes to your crown. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Fresh water floats on salt water, and that simple fact stirs the entire ocean. When sea ice forms near the poles, it leaves its salt behind, making the surrounding water saltier and therefore denser and heavier. That cold, salty water sinks toward the deep sea floor and begins a slow journey across the world, taking centuries to complete a single loop. As it sinks, warmer surface water flows in to replace it. This great overturning is what keeps the deep ocean from going stagnant, and it quietly shuttles heat between the hemispheres for 1,000 years at a time. Mars has 2 tiny moons, and one of them is doomed to fall. Phobos orbits so close and so fast that it laps the planet several times a day, faster than Mars itself turns. Because it circles below a certain critical distance, the planet's gravity is slowly reeling it inward. In the far future, it will either be torn into a ring of rubble or crash into the surface. Unlike our own outward drifting moon, this little world is spiraling down toward the planet it has circled for ages. Many reefs glow with color because the coral is farming light. Inside each polyp live microscopic algae, tucked into its tissue, trading sugar for shelter. The algae photosynthesize and feed the coral most of its energy. That partnership is why reefs cluster in clear, sunlit, shallow seas, and why they don't grow in the dark deep. When water grows too warm, the coral expels its algae, loses its color, and starves. The white you sometimes see isn't decoration stripped away. It is the bare limestone showing through. Roughly 4/5 of every breath you take is nitrogen. a gas your body never uses. Air is about 78% nitrogen and only 21% oxygen, with a thin remainder of everything else. The nitrogen rides in and rides back out unchanged, an inert bystander. It matters anyway. That bulk of unreactive gas dilutes the oxygen, and without it, pure oxygen would make fires burn fierce and uncontrollable. The atmosphere keeps us alive partly with the gas we breathe and partly with the gas we ignore. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. Mountains have roots, and the roots explain why the peaks last. Thick continental crust is lighter than the mantle beneath it, so it floats, the way an iceberg floats with most of its mass submerged. Pile up a mountain range, and you also push a deep keel of light rock down into the mantle to balance it. As wind and rain wear the summit away, the buoyant root slowly pushes the whole range upward to compensate, so a mountain can keep standing tall for ages, refloating itself even as erosion tries to grind it flat. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins, and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. Count the cells in a human body, and a strange thing happens. A large share of them aren't human at all. Bacteria, mostly in the gut, rival your own cells in number. They're tiny, so they barely register as weight. A kilogram or two, no more. Yet they earn their keep. Your gut lining can't fully digest certain fibers, so these microbes ferment them instead, releasing short molecules your cells absorb as fuel. The body that drifts through space is not one organism. It's a moving truce between you and the trillions you carry. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed Venus is wrapped in clouds that rain sulfuric acid, yet the drops never reach the ground. The surface is so blisteringly hot, around 460 degrees Celsius, that the acidic rain boils back into vapor high in the sky before it can land. This furnace is the work of a runaway greenhouse. A dense blanket of carbon dioxide traps heat so efficiently that Venus is hotter than Mercury, though it sits farther from the sun. Thick air, not nearness, makes it the hottest planet we know. An induction stove heats a pan while its own surface stays cool enough to touch. Beneath the glass, a coil carries a rapidly alternating current, building a fast-changing magnetic field. That field plunges into the iron base of the pan and stirs swirling loops of current within the metal itself. The iron resists those eddy currents and heats from the inside, so the pan cooks the food while the glass, a poor conductor, is warmed only by the pan above it. Energy crosses the gap as a magnetic field, never as flame. A honeybee can find a flower on an overcast day when the sun is hidden behind cloud. It reads the sky's hidden grain. Sunlight scattering through the atmosphere becomes polarized, vibrating in patterns that ring around the sun's position like ripples around a stone. The top of the bee's eye holds receptors tuned to that polarization. From even a patch of blue sky, the bee reads the pattern, works out where the sun must be, and sets its course. The whole dome above becomes a compass written in light we cannot see. Governing a great state is like cooking small fish, the Tao Te Ching advises, gently without too much turning. Lao Tzu warns that meddling spoils. A planetary system runs on the same restraint. No hand stirs it, yet orbit after orbit it holds together, undisturbed. Our sun will not explode. It will quietly shrink into a white dwarf, an ember the size of Earth holding nearly half the sun's mass. The reason is mass. Only stars far heavier collapse violently. When the sun exhausts its fuel, it sheds its outer layers and leaves behind its dense core. No more fusion holds it up. Instead, a quantum rule, the pressure of tightly packed electrons refusing to share the same state, props it against gravity. It will simply cool, fading over billions of years. Sagittarius A, the giant at our galaxy's center, is over 4 million solar masses. Yet its horizon would fit comfortably inside the orbit of Mercury. That is the strange economy of black holes. All that mass collapses into a region smaller than a single planetary path. Pack enough weight into a small enough space, and gravity seals it off behind a horizon. The bigger the mass, the wider that horizon grows, but always far tighter than the spread of stars around it. A whole galaxy turns around a dark coin no broader than the inner solar system. Montaigne distrusted grand systems and trusted his own doubt. "What do I know?" and became his motto, paired with the image of a balance weighing every claim. It was not weakness, but honesty, the refusal to mistake confidence for truth. A mind that keeps asking stays open longer than one that has decided. Falling through a cosmos this large, that small question feels less like surrender and more like the only honest map. A spider sits at the center of its web, not just to wait, but to listen. The silk is a sensory instrument. When an insect strikes a strand, the impact sends vibrations racing along the threads to the spider's legs. Different threads carry the tremor at different speeds and strengths. So by comparing what reaches each leg, the spider judges direction, distance, and even the size of the catch. A struggling fly hums differently from a wind-blown leaf. The web is not only a trap, it is an ear spun from silk, stretched across the dark. Inside a dying, massive star, the elements arrange themselves like the layers of an onion. The reason is temperature. The core is hottest, so it fuses the heaviest fuels, building up to iron at the center. Surrounding shells, each cooler than the one within, fuse progressively lighter elements. Silicon, oxygen, carbon, helium, hydrogen at the outside. The star burns through these layers in a desperate, accelerating sequence. The final stages lasting mere days before the core gives way and collapses. A monarch butterfly has never seen the forest it flies toward. Yet generations after its great-grandparents left central Mexico, the descendants returned to the very same groves. The trick lives in a sun compass wired into its tiny brain. The butterfly reads the sun's angle for direction, but the sun moves all day, so it would be useless without correction. So a clock in the antennae tracks the time and adjusts the heading hour by hour. Black out both antennae, and the insect loses its sense of time and veers off course. It is navigating with a sundial it carries on its own. Volcanic ash sounds like destruction, but for archaeology, it is a gift. A great eruption can blanket the land in hours, and that ash layer is nearly identical everywhere it falls. Each eruption also carries its own chemical fingerprint, locked in microscopic glass shards. Find the same fingerprint in an ice core, a peat bog, and a lake bed hundreds of miles apart, and you have strong evidence those distant layers formed in the very same year. One volcano can stitch separate timelines together, linking sites that never otherwise touch. The light from the earliest cosmic glow set out as a fierce orange heat and arrives now as cold microwaves. Expansion stretches the very waves of light as they cross the swelling cosmos, lengthening them, cooling them. What began at thousands of degrees has been pulled down to a few degrees above absolute zero. The journey did not just carry the light, it transformed its color and its temperature. A single storm on Jupiter has raged for centuries and could swallow the Earth whole. The Great Red Spot is a hurricane-like vortex wider than our entire planet, and it persists because Jupiter has no solid ground. On Earth, storms die when they drift over land and lose their fuel. Jupiter is all deep atmosphere, with nothing to break the spinning column apart. Bands of opposing winds pen the storm in on either side, like a wheel trapped between two conveyor belts, turning on and on. Goosebumps are a leftover reflex from a furrier past. When you're cold or startled, a tiny muscle at the base of each hair contracts and pulls the hair upright. In a thick-coated animal, raised fur traps a warmer layer of air or makes the body look bigger to a threat. You kept the wiring but lost most of the coat. So all that remains is the dimpling of your skin. It's a small, honest fossil, a once useful response, still firing on cue, working a fur you no longer have. A white dwarf the size of Earth can be hotter than the surface of the sun, yet it produces no energy at all. The heat is left over. Having ceased all fusion, a white dwarf is simply the exposed, glowing core of a dead star, cooling like an iron pulled from a forge. Because it is so small and dense, it radiates that stored warmth slowly. The faintest, coolest of these embers have been cooling for nearly the entire age of the universe and have barely gone dark. Inheriting a single compass heading can land a young bird in the right place by sheer geometry. Some first-time migrants seem to fly one fixed direction for a set number of days, then stop. It sounds crude, yet it can work, because the route bends around coastlines and the birds bend with it. Older birds do better, having learned a true map that lets them correct for being blown off course. The young rely on a simple inherited rule. The old rely on experience. Both reach the wintering grounds by very different kinds of knowing. Bake a dried tardigrade, boil it, expose it to the vacuum of space, and it can still revive, yet drop it active into the same conditions and it dies at once. The toughness is not in the animal, but in the state. Only when emptied of water and locked into glass do its molecules become unreactive enough to ignore heat, cold, and radiation. Water is what lets damage spread. Without it, the usual chemistry of harm simply cannot proceed. The creature is not invincible. It has learned to become, for a while, almost chemically inert. A robin crossing a continent at night keeps its heading without map or stars because it can feel the planet's magnetic field. The leading idea points to proteins in its eyes called cryptochromes. When dim light strikes them, it knocks electrons into a fleeting pair whose behavior is nudged by Earth's field, subtly changing how strongly the protein reacts. That tiny difference may paint the magnetic field as a pattern of light and shadow across the bird's view. North isn't a number to a migrating robin. It may be something it sees. You can read the violence of an ancient eruption in the size of its leftover debris. Eruptions are classified partly by how high they threw their ash and how much they ejected. And the most explosive ones leave layers of fine ash spread over enormous areas. The reason is the magma's gas and stickiness. Thick, gas-rich melt fragments into the smallest, most far-traveling particles. So a thin gray layer found in soil far from any mountain can betray an eruption thousands of years gone, its fury preserved in dust finer than flour. A halo can ring the sun or moon at a precise 22 degrees, drawn by ice crystals you may never even notice. High, cold clouds hold tiny, six-sided ice prisms drifting in the air. Light entering one face and leaving another bends by a minimum of about 22 degrees and no less. Crystals at exactly that angle relay light to your eye, tracing a bright circle. The empty gap inside the ring appears because the ice cannot bend light any tighter. If you fell into a large black hole, you would not see a wall rushing toward you. The event horizon is not a place your eyes could find. You could drift across it and notice nothing unusual in that instant. Space looks ordinary. You feel weightless, still falling. The horizon is defined only by what happens after. From there, no signal you send can ever climb back out. The boundary is real but invisible, marked not by anything present, but by a future that is quietly closed. You cross the most decisive line in physics without seeing it pass. Divers off a Greek island once hauled up a corroded lump of bronze. Some fish that live in murky, lightless water generate their own electricity to sea. The weakly electric fish pulses a faint field around its body from a special organ, then feels how that field bends. A rock, a plant, or another fish each distorts the field differently. A good conductor pulls it one way, an insulator another. Sensors in the skin map those distortions into a picture of the surroundings. It's a sense we have no word for, building a portrait of the dark from the way its own electric aura is disturbed. Sealed away from all clocks and sunlight, most people settle into a day slightly longer than 24 hours. Left alone, the body's clock runs a little slow, drifting later each cycle. This is why morning light matters so much. Bright light in the early hours pulls the clock earlier, holding it locked to the planet's spin. Without that daily nudge, your sleep would creep later and later, until night and day quietly traded places and the world felt permanently out of step. The first elements heavier than hydrogen were not made in stars at all. but in the opening minutes of the universe. In that brief, searingly hot window, the entire cosmos acted as a fusion reactor, binding protons and neutrons into helium and a trace of lithium. Then it cooled, and expansion quenched the reactions before anything heavier could form. Every atom beyond lithium had to wait for the first stars to live, die, and seed space with their richer ash. Magnetic stripes are frozen into the ocean floor, and reading them proves the sea floor spreads. Now and then, the Earth's magnetic field flips, north and south trading places. Molten rock erupting at a mid-ocean ridge records whatever direction the field points as it hardens. As new crust forms and drifts outward, it carries that frozen compass reading with it. The result is a pattern of parallel bands, normal, reversed, normal, mirrored on both sides of the ridge. Those matching stripes are a tape recording of the seafloor being made, played outward from the seam in both directions. Mars hosts a canyon so enormous it would stretch across the width of a continent. Valle Marineris runs thousands of kilometers long and plunges far deeper than the Grand Canyon. It was not carved by water, but torn open by the planet's crust splitting and stretching, a colossal fracture from when the nearby volcanic highlands swelled and pulled the surrounding ground apart. What looks like a river valley is really a The longest chain of volcanoes on Earth is one almost nobody sees, because it runs along the bottom of the sea. The mid-ocean ridge winds for tens of thousands of kilometers between the continents, where plates pull apart and mantle rises to fill the gap. As that rising rock decompresses, it melts and erupts quietly underwater, paving the seafloor with fresh basalt. There is no explosion here, because the crushing weight of the ocean keeps the gas dissolved. New crust is born in the dark, steadily, all the time, all around the planet. Press your fingertip against the table and feel the pressure. Now ask where the feeling itself lives. Scientists can trace the whole chain. Skin receptors firing, signals climbing the spinal cord, the brain's touch map lighting up. Every step is physical and measurable, yet none of it explains why there is something it feels like to be touched, rather than mere data moving in silence. This gap has a name: the hard problem of consciousness. We can map the wiring perfectly and still not derive the sensation from it. The mechanism is a transformer moves energy between two coils that never touch, using only a shared magnetic field. Alternating current in the first coil builds and collapses a field many times a second, and that swinging field threads through the second coil and drives a current there. The trick is the turns. More loops on the output side trade lower current for higher voltage. Fewer loops do the reverse. That is how power leaves a station at hundreds of thousands of volts for the long haul, then steps down gently before it reaches a lamp. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. is gold yellow when most metals are silvery gray. Strangely, the color comes from Einstein's relativity. In a heavy atom like gold, the inner electrons orbit so fast they gain extra mass and pull inward, shifting the energy levels of the outer electrons. That shift lets gold absorb blue light rather than reflecting everything evenly. Remove the blue and what bounces back to your eye is warm and yellow. Silver, lighter, keeps its electrons slower and reflects all colors alike. Gold's glow is a rare case where a metal wears the visible mark of relativity written across. Black holes are not eternal. According to quantum theory, they slowly leak particles at their edge and shrink, an effect called Hawking radiation. The mechanism is subtle. The boundary between something and nothing is not perfectly clean, and energy can escape as a faint glow. Smaller holes glow hotter and vanish faster. The largest take longer than the present age of the universe by numbers too vast to picture. But the principle stands. Even the darkest objects evaporate, given enough time. Nothing in the cosmos, not even a black hole, is truly permanent. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Some of the most famous towering rock walls were never pushed up as mountains. Instead, a slab of especially hard rock simply refused to erode, while softer rock all around it washed away. As rivers and weather lowered the surrounding land for millions of years, the stubborn block was left standing alone, a sheer monolith rising from a flat plain. It did not grow taller. The world around it grew lower, and what remains is the toughest leftover of a landscape that has otherwise vanished. Horses gave the steppe a near monopoly on speed. For centuries, the fastest way to move people, messages, and goods over land was on horseback, and the open grasslands of Central Asia bred and raised horses in abundance. Whoever controlled that supply controlled the tempo of long-distance contact. Trade and news crossed continents at the pace a horse could be ridden and remounted. The grassland was not just a place traders passed through, it was the source of the very animal that let them pass at all. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. To use the sun as a compass, you must know what time it is. The sun is east at dawn and west at dusk, so its direction is meaningless without a clock. Migrating birds carry an internal clock tuned to the day. Shift that clock in the lab by keeping birds in artificial light hours out of step, and they head off at a predictable wrong angle. The size of the error matches the size of the time shift. It is proof you can almost calculate. The bird's mistake reveals the hidden sundial running inside it. A crystal's flat faces and sharp angles are not carving. They come from the atoms inside. In a crystal, atoms lock into a repeating three-dimensional pattern, the same arrangement over and over in every direction. When that orderly stacking reaches the surface, it ends along clean planes, and those planes meet at angles fixed by the geometry of the pattern. Grow a quartz crystal twice, undisturbed, and the angles between matching faces come out identical. The shimmering shape your eye admires is the hidden lattice of atoms, made finely large enough to see. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. Galaxies cluster because the universe was never perfectly smooth. In its first instant, tiny ripples in density were baked into everything, some regions a hair denser than others. Gravity is patient and relentless. It pulled matter from thin places into thick ones, and the thick ones grew thicker over billions of years. Today, those ancient ripples have become the great walls and clusters of galaxies, with vast empty voids between. The cosmic web we map now is the grown-up form of wrinkles present when the universe was newborn. When a giant star dies, its core collapses in less than a second, falling inward at a quarter the speed of light. The infouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. Double a black hole's mass, and you exactly double the width of its shadow. The event horizon scales straight in line with mass because gravity's reach grows in simple step with how much sits inside. This makes the giant strangely roomy. The most massive holes, billions of times heavier than the sun, can have horizons spanning the scale of a planet's orbit, yet the curve of space across them is gentle. Bigger holes are paradoxically less violent at the edge. Mass and size march together, one for one. A rare clean ratio in a universe that loves to complicate. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. Some of the oldest rock on land is far older than any rock on the ocean floor, and that gap is a clue to how the planet works. Continents are made of light rock that resists sinking, so they ride on the surface for billions of years. Ocean floor is dense, and dense rock eventually dives back into the mantle and melts away. So the seabed is constantly destroyed and remade, never lasting long, while the continents endure. The Earth keeps its lightest material on top and quietly swallows the rest again and again across deep time. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows. Light from a far cosmic explosion arrives stretched and delayed compared to a closer one, and that difference reveals expansion. Light from a nearby blast comes through quickly. Light from a distant one is lengthened by the growing space it crosses. By comparing how stretched the light is against how distant the source must be, astronomers chart how the cosmos has expanded across its long history. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. Even across a room, you are seeing the past. A face 3 feet away reaches your eyes a few billionths of a second after the light leaves it. The delay is far too small to notice, yet it is real and unavoidable, because light needs time to travel any distance at all. There is no such thing as seeing something exactly as it is right now. Every image, near or unimaginably far, is a message that left before you received it. Sight is always slightly delayed. Two parallel wires carrying current in the same direction pull toward each other, with no magnet in sight. A current makes a magnetic field that circles around its wire, and the second wire, carrying its own moving charges, feels a force in that field. Run the currents the same way and the force is attraction, reverse one, and the wires push apart. This silent tug between currents is so fundamental that it once defined the ampere itself, the very unit by which we measure electric current. A small striped wrasse sets up a stall on the reef and waits. Larger fish line up, hold still, even open their jaws and gill covers, and let the little fish swim inside to pick off parasites, and dead skin. Why doesn't the big fish simply eat its tiny dentist? Because a working cleaning station is worth more than one meal. The visitor returns day after day, and a predator that swallows its cleaner loses the service for good. Cooperation here is just patient self-interest. Most of the microbes in your gut could never survive in open air. They live without oxygen, which to them is poison, thriving only in the airless depths of your intestine. This makes the gut one of the largest oxygen-free habitats carried inside any animal. A hidden anaerobic world, kept warm within every person. The figure falling through the vacuum of space holds a vacuum of its own kind within. A vast inner ecosystem that would die the instant it met the very gas keeping its host alive. General anesthesia does not work like a stronger painkiller. A painkiller blocks the signal, anesthesia switches off the experiencer. The drugs reach neurons everywhere, yet their decisive effect is on coordination. Awake, distant brain regions talk back and forth in fast, integrated loops. Under anesthesia, those long-range conversations break apart. Local patches still fire, but they stop sharing information across the whole. Awareness seems to depend less on neurons being active and more on them being connected. Switch off the conversation and the lights stay. Your two ears are spaced a hand's width apart, and that small gap is how you find a sound in space. When something calls from your left, the wave reaches your left ear a fraction of a millisecond before the right and arrives a touch louder since your head casts a faint sound shadow. Your brain reads these tiny differences in timing and loudness and computes a direction. It's why a sound directly ahead, equal in both ears, is the hardest to place, and why tilting your head, changing the gap, helps you pin it down. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe one explosion at a time. A pit viper can strike a warm mouse in absolute darkness because it doesn't need light to see heat. Between each eye and nostril sits a small pit, and stretched inside it is a membrane as thin as tissue, dotted with nerves that respond to infrared warmth. A nearby body radiates heat. That radiation warms one patch of the membrane more than another, and the nerves report the difference. The brain merges this heat image with ordinary vision, so the snake effectively sees a glowing outline of anything warmer than its surroundings. Watch a waterfall for a minute, then look at the rocks beside it, and the still rocks seem to drift upward. Nothing moved. Motion-detecting cells in your brain, tuned to downward flow, weakened while you stared. When you look away, their quieted signal is outweighed by the cells tuned to the opposite direction, and the brain reads that imbalance as upward motion on a surface that's perfectly still. Its vision caught mid-calculation, showing that even "this is moving" is a verdict the brain computes by weighing competing votes. Votes you can tire and tip on. Strike-slip faults grind sideways, and they can slice straight through the landscape like a knife through layered cake. The two blocks slide horizontally past each other, so a river, a fence, or an ancient road that once ran in a single line ends up offset, its halves carried apart by meters with each great quake. Geologists read these displaced features like a logbook, measuring how far the ground has jumped over thousands of years. The crookedness in the land is the fault signature, the visible sum of countless invisible lurches. Much of your immune system sits wrapped around your gut. It seems excessive until you remember what the gut is: a long tube open to the outside world, lined with food and trillions of microbes. The body's largest meeting point with the outside isn't your skin, it's this inner surface, folded to a surprisingly vast area. So the immune system stations much of its forces there, learning constantly which microbes are tenants and which are threats. The deepest border you patrol runs through the middle of you. The unexamined life is not worth living. Socrates says it at his trial, in Plato's Apology, refusing to stop questioning even to save himself. His claim is sharp. A life never turned back on itself, never asked about, is barely a life at all. Examining means catching your own assumptions and testing them. Falling silently through the dark, with nothing to do but look inward, is exactly the condition he prized. Attention turned, at last, on the one who was looking. A black hole has no surface. The event horizon is just a boundary in empty space, the radius where escape would require moving faster than light. Cross it falling, and you might feel nothing at all in that moment. Yet outside, that line is absolute. Light itself bends inward and never climbs back out. The darkness you picture is not an object made of matter. It is a region defined entirely by what cannot leave it. The hole is a place, not a thing, a sphere of no return drawn in geometry, not stone. That faint smudge called Andromeda is the most distant thing the naked eye can see, and its light has traveled about 2.5 million years to reach you. Its glow left before our species existed, crossing all that time for a single human eye. Because light moves at a finite speed, distance becomes delay. The farther a thing sits, the deeper into history you see it. So you are not seeing Andromeda as it is now, but as it was when our earliest ancestors were first shaping stone tools, a postcard mailed before there was anyone to read it. When a giant star dies, its core collapses in less than a second, falling inward at 1/4 the speed of light. The enfouling matter slams into the newborn neutron core and rebounds, and a flood of ghostly particles called neutrinos pours outward. Almost all of them pass straight through the star, but enough push back to blow the outer layers apart. That rebound and neutrino blast is a supernova, briefly outshining an entire galaxy of 100 billion stars. Alexander the Great once stood over Diogenes, who was lying in the sun, and offered him anything he wished. "Stand a little out of my sun," the philosopher answered. The most powerful man alive asked only to stop casting a shadow. It is a lesson in scale. Warmth freely given outranks empires offered. The lone traveler below asked the same of every passing star. Only light, nothing more. Divers off a Greek island once hauled up a corroded lump of bronze. matches the daily pulse, you get a single tide. Where it matches the twice daily pulse, you get two. The moon supplies the push, but the bowl beneath the water decides how the answer comes out. Sound is the deep ocean's true long-distance sense, not sight. Light dies within hundreds of meters, but sound travels for kilometers through water, faster and farther than through air, because water is dense and carries vibration well. This is why the largest whales sing in deep, low tones. Those notes can cross an entire ocean basin. Where eyes are nearly useless, the deep becomes a world of listening, and a single call can reach a companion an ocean away. Glass beads were once a currency of ideas. Along ancient routes, small, worked glass beads turn up thousands of kilometers from where they were melted because they were compact, durable, and desired everywhere. To trade a bead was to trade a sample of a distant workshop's skill. Where the beads went, the appetite for that craft followed, sometimes the craft itself. The humblest object in a caravan could carry the reputation of a city no one in the receiving market had ever visited. The bones of a sunken whale can power life for years after the flesh is gone, and the trick is hidden inside them. Whale bones are soaked in fat, and specialized worms and bacteria break that fat down for energy. Some bacteria even produce a chemical that other creatures, in turn, feed upon. So a skeleton becomes a slow-burning engine, releasing stored energy long after the body has vanished, feeding a community built entirely on the riches locked inside the dead. Fever feels like the body breaking. It's the body deciding. When immune cells detect an invader, they release signals that travel to the hypothalamus, the brain's thermostat, and tell it to raise the set point. Suddenly, your normal temperature reads as too cold, so you shiver and feel chilled, making more heat. The higher temperature isn't an accident of illness. It's a chosen state. Many bacteria replicate best near normal body heat, and a few degrees more slows them while speeding your own defenses. The thermostat was turned up on purpose. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. A single quake sends out two kinds of body waves, and one always wins the race. The P wave pushes and pulls the rock along the direction it travels, compressing it like a sound wave, and it moves fastest. Behind it comes the S wave, shaking the ground sideways across its path. Because P waves arrive first but carry less punch, seismometers often record a faint warning jolt before the heavy shaking lands. Early warning systems live in that narrow gap. The letters even hint at it. P for primary, S for secondary. Some of the worst tsunamis come from the gentlest seeming quakes. In rare tsunami earthquakes, the fault slips slowly through soft, waterlogged seafloor sediment, so the ground barely shakes and coastal residents feel only a mild, drawn-out roll. But that slow slip still heaves a vast area of seabed upward, displacing an enormous volume of water. The mismatch is the danger. Weak shaking lulls people into staying put, while a large wave is already on its way. The sea's response is far bigger than the tremor suggested. A neutron star's surface may be smoother than any object you have ever touched, with mountains no taller than a few millimeters. The reason is its crushing gravity. Any bump tall enough to matter would be flattened instantly by a gravitational pull hundreds of billions of times stronger than Earth's. The entire star, heavier than the sun, is sculpted into an almost perfect sphere. Its tallest features lower than the thickness of a coin, polished by gravity into near-flawless smoothness. Told that the people of Sinop had condemned him to exile, Diogenes shrugged one another and stopped. That contact is the signal to halt. Healing isn't the body filling a hole so much as a living surface flowing across it, knowing exactly when the wound has become whole again. A snake with no outer ears can still sense a footstep coming. It listens through its jaw. Vibrations travel through the ground far better than through air, and as they ripple under a resting snake, they shake the bones of its lower jaw. That jawbone connects to the inner ear, so a tremor in the soil becomes a sound inside the snake's head. Because the two sides of the jaw can be jostled slightly differently, the snake may even sense which direction the disturbance came from. The ground itself whispers to it. Some bacteria in your gut actively defend their turf with chemistry. They produce small toxins called bacteriocins, narrowly aimed at rival strains competing for the same space and food. To you, it's invisible, a microscopic war fought in your intestine to decide who lives there. But the outcome matters. When friendly residents win these battles, they keep the population stable and leave fewer openings for harmful invaders. The peace in your gut is not calm. It's a balance held by countless small skirmishes you never feel. Saturn is so light for its size that, given a bathtub big enough, it would float on water. The planet is made mostly of hydrogen and helium, the two lightest elements, with so little dense rock that its average density is less than water's. Despite being wide enough to hold hundreds of Earth, the whole giant is essentially a vast ball of gas. Mass alone does not make a world heavy for its bulk. What it is made of matters just as much as how big it grows. Nearly every atom of gold in existence was forged in catastrophe. Stars fuse hydrogen into helium, then heavier elements, but the building stalls at iron, because fusing iron drains energy instead of releasing it. So how do we get gold, platinum, uranium? In the violence of collapsing stars and colliding neutron stars, free neutrons flood in faster than atoms can decay, building heavier and heavier nuclei. The ring on a finger carries metal assembled in some of the most extreme events the cosmos allows.